Welcome back to our Chem 152 video series. Today we'll be talking about Kp versus Kc values. The reaction we are given is 2NO2 yields N2O4. If the temperature is 25 Celsius, the Kc for this value is 160. The question asks us to find Kp at this temperature. Let's define Kc and Kp. We've seen previously that K is equal to products over reactants at equilibrium. But K will not always be the same value because it matters how we define our concentrations. Kc is our equilibrium constant if we are using molarity as our concentration. However, when you're doing a reaction with gases only, it's possible to look at Kp, which is the equilibrium constant based on pressure. A K value that uses molarity as the units may end up as a different value from a K that uses pressure. Sometimes it helps to be able to go between Kc and Kp, depending on whether we'll be using molarity or pressure. In this problem, we are given the Kc, but we are looking for the Kp. The equation we use to go between them is that Kp is equal to Kc times R times T, the quantity raised to the delta N. Now the R value that we'll use is going to be 0.0821 liter atmospheres per mole Kelvin. The temperature that we're going to use here is going to be in Kelvin. You cannot use Celsius. Delta N is going to be the change in moles of gas. For this, we'll need to look to the equation itself. Notice that we start with 2 moles of gas because our coefficient is 2. But at the end, we have only 1 mole of gas because we have no coefficient written. So we'll write in the invisible 1. If we're going from 2 down to 1, to find the change in the moles of gas, we take 1 minus 2, and this will give us a delta N value of -1. We'll also write down that R is 0.0821. We'll write down that Kc was 160. And our temperature, T, is going to be the 25 Celsius we started with, plus 273.15 to change to Kelvin. This gives us a total of 298.15, which means now we know Kc, R, T, and delta N, and now we can place the numbers in their correct positions. We'll say Kp equals Kc, which is 160, multiply times R, which is 0.0821, multiply by temperature, which is 298.15, and then raise that parentheses to the delta N, which was -1. We will get 6.54 for our final Kp. So you can see that K, in terms of pressure, can end up looking completely different from K in terms of molarity. Thank you for watching, and we'll see you again soon.